The question was...
What's 30? What is it?
Parentheses, secant x minus tangent x, parentheses again, secant x plus tangent of x over secant of x.
The whole thing's over secant?
Yeah.
Okay, so let's talk about that. Look, even if only one of them were over secant, the fact that it's all multiplication means you can just make it all over secant. Like, you don't need a common denominator for multiplication. Okay? So this is just all over secant.
Secant 1.
Oh, they're y's instead of x's? Yeah, it doesn't matter. Okay, that's fine.
Is y and the top is...
No, they're all y.
Okay. Yeah, for the most part, like, you should be seeing the same thing in all these parentheses for right now. Okay. Anyway, what's this look like this is just begging you to do here?
Change everything to signs and cosines.
You could switch signs and cosines. So my rule for that, I guess, is you could do that if you're stuck. But you definitely want to do that if you have like a sine or a cosine mixed in with other functions. So if you have like a sine and a tangent, sine and cosine is a good way to go. But we don't have any sines or cosines here at all, so switching the sines and cosines is going to make this really complicated. We're going to have, and I'll do it that way too, and I'll show you how it works out. But I think it's easier, like, you just multiply out the top. Do you see this? Okay? If you FOIL out the top, they're conjugates. Do you see that they're conjugates?
Yeah.
So when you multiply them together, you just get the first one squared minus the second one squared all over secant of x still. Are we okay with that?
Yeah.
And it turns out that secant squared and tangent squared are in a Pythagorean identity together. Okay? So, you can plug in a couple different ways here, but secant squared minus tangent squared from our Pythagorean identities is 1. Let's talk about why that is real quick. We have this Pythagorean identity, and this is the way we learned it. We okay with that?
Yeah.
So if you just memorize that, look, you can just take that tangent squared plus 1, which is secant squared. With me here?
Yeah.
And when you come back over to this identity, you see where we see that secant squared? I can just put in a tangent squared plus 1, because that's what secant squared equals. Is that okay? So we can do it that way if you want to think of it like that. Tangent squared plus 1 minus tangent squared. Is everyone okay with that? No questions. Technically, that should be in parentheses, but they don't really matter in this case. Anytime you do a substitution, just be in parentheses. But the top then just reduces to 1, and that's over secant, and that happens to be cosine of x. And while you're right there, and while we're on the topic of this thing here, like, you don't. So what I did from this step to this step, you don't really even need to do that if you're thinking, because you can hopefully rearrange things in this equation to get secant squared minus tangent squared. If you move it over there, right? That just equals 1 all by itself anyway, so you can just drop a 1 in there. But if you're stuck, you can always just do a substitution like I did and simplify it down. Okay, so we get cosine. So let's go back for a second here. Ready? Check this craziness out. Okay, I know. Yep. Okay, so this is our original problem. Just to go through it so we can see what this looks like, if we wanted to switch everything to sines and cosines, which I think is way more work here, but I want to do it just so we go through the algebra that we're allowed to do. Yes, okay. Because most common thing I see kids doing in Calc 1 and 2, or the mistakes, are they start doing math that doesn't make any sense. That's not true. You know what I mean? They start canceling things that don't cancel, or they multiply things together and get the wrong answer or something. So anyway, let's just do this and look at how we can handle this. Secant 1 over cosine. Can we handle that?
Yeah.
Tangent is sine over cosine. So there's nothing wrong with that. We can do that. Boom. Times secant is 1 over cosine. And then you got all of this junk. Whew. All over 1 over cosine. Is that okay? Now something I would do, because secant's down there all by itself, I wouldn't write that as 1 over cosine. Secant on the bottom is the same thing as what in the numerator? Cosine, yeah, so rather than making this down here a 1 over cosine, we can literally just take this and slide it right up here next to everything. That's how fractions work, okay? So anyway, now we can distribute the cosine if we wanted to. We got all this crap to multiply out, but if I distribute this cosine, we get, in this case, 1 minus sine of x. Is that okay? That's in parentheses, and that's being multiplied by, these have a common denominator here, so that's 1 plus sine of x over cosine of x. How are we doing? Oh, this is really over 1. Again, this is way more work, but this is still working out. I'm going to go through, again, the rules here, but we can multiply these fractions together. I can do 1 minus sine times 1 plus sine. That happens to be 1 minus sine squared, and that's over 1 times cosine, which is cosine. And 1 minus sine squared is cosine squared x over cosine, and oh my goodness, we get cosine, which is the same thing we had originally. Okay?